Yeah, I think that's a great point. Like that is one of the challenges is trying to actually finish one of these, like setting the scope reasonably so that you can actually complete one of these projects. And obviously, like it's something that'll probably never be done, but you can continue to improve and iterate. So I know Tyler mentioned this too last week, but like he has heard Z encourage a lot of people to basically start with as simple as possible and finish that, and that might take like 2 weeks, and then you add complexity, and that adds another 6 weeks, and you add complexity, and that adds 6 months, and then so you kind of can expand from there. So maybe that could be a good way to like try and break it down and feel like you're making progress instead of just marching against a 3-year timeline.
Yep, that's the approach I'm taking.
Cool. Awesome.
Actually, it should be the other way around.
Sorry? You think it should be the other way around?
Yeah, you should reduce the complexity and get something done.
Oh yeah. I think that's kind of what I was trying to explain. Like reducing the complexity so that you can make progress and complete stages, and then as you add complexity, then the project will obviously continue on. But and the other thing I'd add too is that I know some of us are like choosing less general and more specific systems or models that we want to build, and kind of using this as like resources and a forcing mechanism or whatever you want to call it to actually put some work in on this and have resources of mentors and peers to help. But that said, I still think it would be great if part of your projects or some sort of like deliverable can be submitted to the cadCAD community, like the Commons, whether it be just an article saying, I thought modeling was going to be easy, it ended up being hard, and like explaining your experience, or if it's a model like an open source model with some notes in it just to help other people understand, like get a feel for what a cadCAD model might look like, whether it's predator prey or bonding curve or whatever. But if there's any points along the way with your project or the system that you're modeling that you could potentially turn into contribution to the cadCAD Commons too, that would be awesome. So that would be, I guess, my other comments about long timelines and seemingly never complete projects. But cool. Then any other comments or questions?
Hey, this is I am a new command.
Sorry, I'm having some trouble hearing you, Kushrishi.
Is it better now?
Yes, yeah.
Hi there. So I was just saying that I'm a newcomer, and this is my first cadCAD session. I did kind of go through some of the materials, and I'm quite interested in this tool specifically. I've got a reasonable, programming experience and things like that. But I was just wondering where to get started with this whole thing. I was just listening in the background, and it looks like you guys are already, working on some kind of projects or things like that. So if you can guide me in the right direction, I can probably take it up.
Yeah, totally. So this is the cadCAD study group, and we've all kind of picked a learning goal or project or system that we are working on modeling, or that's at least what most people I think have gravitated towards is kind of picking a system. And we also have varying degrees of programming experience or just systems modeling experience. And we're all just kind of working through the process together. So, honestly, I think the study group would be a great place to start. I'll send the link to this one-stop shop, the document that I'm sharing on my screen, and it has some resources on the first page here that we have collected just over the last few sessions. That these are also good resources for hearing a little bit more about cadCAD and generalized dynamical systems, and yeah, so just maybe digging around the one-stop shop would be a good place to start to understand the study group a little bit more. And then I can also drop some other links to like cadCAD onboarding, Notion documents, and stuff like that from a little bit outdated, but they're still helpful information. So
awesome. And where can I find those links? Would you be posting them on the town hall chat, or?
Ooh, I'm sorry, I couldn't hear that one again.
I'm saying, where will you be posting the links again? Sorry.
Yeah, I'll post it right in the cadCAD study group Discord channel. And let me just find it, and I'll tag you.
Awesome. Awesome. I just had another question, though.
Cool.
So I'm also working for a DAO, and although I'm not directly involved in the tokenomics, we're still working our way out there, and we would definitely want to kind of model our system, run some simulations, and see how we can kind of set up an efficient feedback loop as well.
Mm-hmm.
So when you say projects, are you referring to projects that individuals are working on in the background, which they would want to bring in and kind of start playing around with? Or are you talking about some bootstrap projects that you already have, which will kind of give us an idea as to how to use the tool, how to run simulations and things like that?
Yeah. So it was a little hard to hear the second half of that, but the projects that everyone's working on in here, they're more or less personal projects. They might be taking it from, inspiration if they're working with another crypto project or maybe in another DAO and they're working on that. But otherwise, I think it's mostly just personal interests or whatever has come to mind or excited people. That's kind of what we wanted, is just to give people a chance to work on the systems that they know the best, they're most interested in, and want to start modeling. So it's definitely free to pick what you'd like. But I'd also encourage you to watch the kickoff session recording of the study group, because we also explain a little bit more about like the goals of the study group and contributing to the cadCAD Commons as with a deliverable, with like a public into the public repository, or with documentation or articles or something. So while you might be working on your own project, there's also giving some back to the cadCAD community as part of participating in the study group. So, but yeah, welcome, and I'll definitely add some more content, or some like intro content to the Discord voice channel, and I'll also pin it just so other new people can find it there too.
Thank you very much. Really appreciate it.
Yeah. And I see Danilo joined us too. So, hey Danilo, thanks for coming. Thanks for joining. If you want to say hi.
Yeah, everyone.
Yeah, cool.
Hello.
Nice. So we were just about to get started, just kind of collecting some questions. So I'll pause once more, see if there's any questions before we jump into the presentations and pitches from the sign-up sheet.
Yeah, I'd like to ask, Danilo one question. When will version 1, and cadCAD 1 be ready? The first one.
Sorry, I didn't. Were you asking about cadCAD 1.0?
Yeah, cadCAD. Yeah.
Oh yeah. I haven't heard any updated timelines on that. I know it's still being worked on. Tyler isn't here this week, unfortunately, but
I was asking, Danilo.
Oh, okay.
Yes. So about cadCAD 1.0, So first thing is that the development is open source. It's happening on the cadCAD organization, mainly on the branches. In terms of timeline, we do not have an estimate, but one thing that, actually this is it's one of the attributions that I took for myself. In the next weeks, we are going to build some integration tests. And those integration tests, they are going to encapsulate the typical use case. So the idea is that by having those tests, we can keep track about, for example, what's missing, what has been done. So I do expect that over the course of, let's say, maybe 3 weeks, we'll be able to, let's say, to have a sort of a progress bar to get to know, for example, how much time. But if you were to ask me about, let's say, when we can start to playing with cadCAD 1.0, if we were to, let's say, suppose that I need to make a bet. I would bet that, let's say, we could start playing in maybe 3 months from now, but probably the final release is going to be a bit longer than that. But I do expect that over the course of 3 weeks, by having those tests and, let's say, encapsulating some of the use case, we'll have a better gauge and, let's say, we'll have a progress bar on it. So that's the answer.
Mm-hmm.
Okay, thanks. That's kind of realistic because actually you're giving a time horizon of something between 3 and 6 months for the full-fledged version.
Yep. Cool. Awesome.
Okay, fine. Yeah, that's fine. I mean, this is a totally rework.
Sorry, I didn't catch the end of that, but I think we got the question answered mostly. Sweet. Thanks, Danilo. Then, yeah, let's just get started. Okay, so I'm on the one-stop shop here.
Really quick. I just downloaded, I had to restore my computer, and I'm no longer able to download the cadCAD re-implementation. It's telling me error, the version is not found. How can I go ahead and fix that?
Ooh, I didn't catch that either. Sorry.
I said, can you hear me? Is it any better?
Yeah, it's a little windy or something.
Forget it. I'll access it.
All right.
Thank you.
No worries. Feel free to drop a message in the Discord channel if that's easier. But all right, cool. So we're in the one-stop shop. Just going to jump to, oh wait, no, we don't need to look at these yet. So for anyone who hasn't entered the sign-up page yet, this is where we are signing up to basically build the agenda for the day, or for each week, and give anyone a chance to reserve some space basically to either pitch a new learning goal or get some feedback on an existing one that we've heard about before. And so just to give people a chance to reserve some space. And it looks like we have 5 signups for today, although Joe's Kojak will probably postpone, so we've got 4. But let's jump into it. So lemp.eth, I think you have been working on it for a couple weeks now, so we're excited to hear the pitch. Prisoner's Dilemma.
All right. Hey, everyone.
Yeah, I'll hand it over.
Christian. Thanks. Let me share my screen. I'm going to present some stuff and talk through what I'm trying to accomplish here.
Cool. And just a reminder for everyone listening, I think it would be like kind of the hope for these presentations is that we're able to offer some feedback, whether it's resources that might be helpful, similar projects, or models that we've seen in the past, or I don't know if we have experience working on these models, any challenges that we foresee, or potential feasibility, like this model is going to take 6 years to complete, comments and stuff. So just keep that in mind while we're presenting, and we'll have comments and discussion afterwards. So cool. Go ahead, Limp.
All right. So the background here, I'm trying to produce a model that uses like a genetic algorithms for selecting the strategy of iterated prisoner's dilemma. So my background, I'm working on a PhD right now in system science and complex systems, and mainly focused on like nature-inspired algorithms to research like coordination games or of people, or collective action problems, basically. So I read this paper. I had to present it. It's called Evolutionary Phenomena in Simple Dynamics. It was written in 1991. A cool paper that is anyone's familiar with like David Axelrod's Prisoner's Dilemma, iterated Prisoner's Dilemma. He kind of lays this out, but then adds a mechanism in here. So I'm not going to go through this whole paper. I've already done that and understand it pretty well. But he lays out kind of like a mechanism for assigning like genetic algorithms to how agents play this Prisoner's Dilemma game, classic game theory, and then demonstrating like population dynamics. So I know somebody said they were working on a model, the Locke-Volterra, population dynamic model. Similar sort of thing happens, and so he gets pretty cool results at the end of like new strategies. You can see this. This is his results in the paper, iterated over 30,000 time steps of the simulation for a certain number of agents, and then just showing how new strategies emerge with these genetic behaviors like reproduction of strategy, mutation, things that happen actually within our genotypes that then express to the sort of traits that we have as people. So interesting problem, cool problem, and I wanted to use it as a template for me to learn cadCAD. So far, anyone with me? Any questions? What I was going to present real quick is just a kind of a description here, just a presentation of how the like encoding works. So we're working with like 2-bit strings of zeros and ones, and that's to denote the action. First of all, and anybody here not familiar with Prisoner's Dilemma, I can explain it extremely quickly. Here's silence. I think that mostly means everybody knows about it. If not, there's a payoff matrix that looks like this. 2 agents meet, and they can choose one of 2 actions. They can cooperate, and if they both cooperate, they get this payout. If one cooperates and one defects, the one who cooperates gets punished, and the one who defects gets rewarded. And then if they both defect, they both get punished. So it's like how to figure out a strategy that wins here. If you remember what your opponent did the previous step, or a few steps prior, can you use that information to have a better strategy and have a better overall outcome here. This is the payoff matrix that we're focusing on. So the way it's encoded is there's a memory, like there's how many previous steps can be remembered. So for example, if the memory is 1, then there's really only one strategy that's possible. Or there's 4 strategies that are possible, right? Because the last action could have been a 0 or could have been a 1. And then there's 4 strategies you could have. When your opponent last defected, you could then follow and defect. When your opponent last cooperated, you can follow and cooperate. This strategy is known as tit for tat. But you could, change this. You could always defect, you could always cooperate, or you could do the reverse tit for tat. Making sense so far?
Yep.
So where I imagine cadCAD coming in here, and I want to try and figure out, right? So some of the genetic mutations here, if a reproduction of a strategy happens. So for example, a 0-1 then you have one more moment in history you remember. So you remember not only your opponent's last action, but you also remember what you did, you being the agent, right? Each agent is keeping track of what all the other agents did, right? So we're iterating through, and every round, every agent's playing every single other agent in the game. And we iterate over a finite number of time steps. So, for example, if the memory increases by 1 additional, so here we remember what the opponent did, and then the next one is remembering what the agent remembers itself, what it did its last round against this opponent, and then if, next time it's faced, if remember that the opponent defected and the agent itself defected, there's all these possible strategies now, right? So the agent selects one, and then it evolves over time, and that's where you start to see, remember this graph down here, these different lines are the proportion of agents in the population using this strategy, right? So there's some like rewards for fitness, right? So if like strategy is doing well compared to other strategies, then it starts to take up more of the population, right? So the idea of like kind of population dynamics here. So that's what's happening. This 1, 2, 3, 4. So the agent remembers 4 previous moves, its opponent's previous move before that, and its own move previous before that. And then over time, it gets pretty crazy and start to have really long memories, and they'll start to kind of win out against all these other strategies, right? So there's like more information now encoded. So where am I at with this?
That's a good question.
Go ahead.
Are the agents facing off against the same agent each round, or is it sort of randomly selected?
Each agent is facing every other agent every round, and they're keeping a memory of what each opponent did in that round, too.
Got it. So
you're
sampling the full space each round, basically.
Exactly. Yep. Full space every round, keeping a recording history of the memory of that playing the game against that specific agent. So I'm pretty familiar with making agent-based models, and so what I'm not familiar with is cadCAD that much. And so I started to just kind of code this out and see what it would look like, and I have an agent class, and I have, randomly selected strategy, and I've started to do this, but let me go to my learning plan here so that I can get an idea of my goals here, what I'm trying to accomplish. So I really want to develop an agent-based model in cadCAD. I think it's a really cool framework that seems very powerful, and I want to become good at it. I'm interested in like tokenomics and governance engineering and those things too, so I feel like cadCAD would be a good skill for me. Implementing a genetic algorithm for game theory problems. So it's pretty, like, I understand it's pretty conceptually, but then implementing it as I'm going through, there's all these like moments that I'm like, oh, the paper didn't explain this like one specific detail that kind of I either have to make a choice or like, ask the author of the paper what they meant in this implementation detail. So I get really good understanding of genetic algorithms by doing this problem. I want to become proficient in configuring cadCAD, so saying like, what happened if I did a sweep of this parameter? Could it change these results? And then I want to present my work and show what I've worked on and help other people learn how to think about genetic algorithms, agent-based models, and simulation of people games. So steps I'm laying out here. Read the paper and understand it. I've already done that. I feel like I understand the paper pretty well. Started to code a simple iterated prisoner's dilemma, not with cadCAD, but just to like get the mechanism of iterating against like a full sample of every other agent and playing the game and having different strategies. That's in progress. I'll show that in a second. Then I want to introduce having like, remember I talked about having multiple memory step strategies. That's probably next. Then the genetic mutations. So Point mutation, that's where, like, in the usual scenario, one would defect, but the point mutation, they actually now do the opposite action. Gene mutation and duplication, these are all just like, genetic modification functions that I want to implement. I want to be able to collect all the results and make a graphic and then write my essay. So I've got a GitHub repo going here. This is public. Anybody can take a look. Got some code started here. Not cadCAD though. Yeah, that's it. Fill out the README, make it reproducible, write it up. That's my goal basically. And here's a couple of resources. So, I guess I'll pause there. One of the things I'm challenged with is like setting up cadCAD. So like I've gone through and looked at a lot of stuff, but like I'm stuck a little bit with how to represent an agent and how to access like a data structure that represents the memory and how to set up the iterated prisoner's dilemma to be simulated using the cadCAD configurations.
I just have a quick question. Where do you see the randomization of the data that you want to sort of model? I was thinking, do you want to just randomize that they react like they're randomizing their option for the tit for tat, the negative tit for tat, the or do you want to randomize, more memories and at different intervals so that one prisoner might remember, more than the other? I was just curious where you want to randomize, because that might help you in building your model, because cadCAD's really good at the Monte Carlo randomization. Over.
So the randomness, at least in the paper, right now, they all start like the seed, the initial strategies, so always defect, always cooperate, tit for tat, anti-tit for tat, in a fixed proportion. And where the randomness comes in are the mutations. So from the paper, the author used a probability that is similar to what I guess is found in actual genetic research of how often does accident genetic mutation occur, and those probabilities are injected for example, if an agent would have done a defect but then chooses to cooperate, the randomness is the probability that that mutation would have occurred, and that aligns at least with, I don't know, what's been discovered in actual genetic research. So then doing it many, many times, you'd be able to see, like, does the same strategy keep coming out, or does different strategy emerge every simulation, or like every what's the range that the Monte Carlo produces is an interesting question to me. Does that make sense? So to be succinct, the randomness is the mutations that happen to the strategy along the way as the simulation is playing out.
So the state you want to measure, the state that you want updated, is the deviation from sort of the initial sort of strategy?
Yeah, so the randomness. So for example, let's imagine this agent here, this memory 2 agent, is employing this strategy. So there's all these possible strategies, but the agent, let's say, for example, happens to be using this one. right here. So one of the randomness could be, so here's the strategy. What the randomness could be is that this sorry, I'm trying to figure out how to move this up to the front, is that this is 0, for example. So when the history 0-1 is encountered, right? So they face an opponent with their history 0-1, meaning the last round the opponent cooperated, and that same round this agent itself defected. So when then this memory is encountered with that agent, the strategy says to defect, but the randomness might be that instead this is a mutation occurs and this 0 becomes a 1. And so they adopt a different strategy than what they originally had. And if that strategy then is effective and wins more often, then it's more likely to reproduce into the population and be adopted by the other agents.
This is super interesting. I'm so I'm kind of curious. What do you think the like most challenging part will be? Do you think the memory, like implementing the memory piece, will be a challenge in cadCAD, or are you mostly wondering, like, looking for advice or suggestions on the agent-based approach, like generally?
I don't know how, like, I've gone through, I understand like the policies and the action, but I actually don't know how to like set up an agent-based model, and I haven't really found the documentation to be helpful for this problem, right? Mm-hmm. Where it's like discrete number of agents, each agent is interacting with other agents, and it's not a model that I'm taking into like a continuous form that can just be turned into a function. Like, it actually has to go through these steps and like do the simulation and these interactions. And that's the part that I'm a little lost, like figuring out how to set up the cadCAD to begin with. Like for example, like I go through and I look at like partial state update blocks, this stuff. I don't like have a good example of like what these are. You know, I like look at this and like I don't quite understand like what am I supposed to put in here. One thing
that might help, I can send along. There's it's kind of old now, but it's a cadCAD onboarding Notion page from like maybe a year ago that has a bunch of template models, and there are some agent-based examples, and they would also help out with like the basic setup of like state update parameters, how to set up the experiment and stuff. So you could probably look at some real examples there. And I know there's 1 or 2 agent-based models in that library also. So those could be good places to start.
Yeah, send along.
Cool.
Send along
or if anyone else has experience with the agent-based modeling stuff, feel free to jump in.
I do have a bit. The thing about agent-based models is because, I mean, one thing is how you represent the agents on the code, and another thing is when you interpret something as agents. So it's always a tricky thing. So I did send on the study group channel it's a demo that I did create 1 year ago. And it's also about the repeated prisoner's dilemma. And you could say that it's an agent-based model. So one approach that usually we do is you need to define the agents on the state variables. So you need to have a state variable that is going to be a matrix or maybe a list. And there are several approaches. So for example, one approach is you define a Python class or a Python data class or a struct. And that class or struct represents the state of the agent. So, for example, how the agent is going to take the decision, the agent metrics, it could be defined on that class. And yeah, I thought that you have defined that class. So, for example, on cadCAD, you would have a state variable that is a list of agents. So you need to mutate that list on each partial state update block. And one good practice when you're doing agent-based modeling on cadCAD is that when you define those classes, it's a good idea to, let's say, make sure that the class does not mutate itself. So if you have any method that is going to mutate itself, usually this leads to, let's say, spaghetti code. So the approach that I like to use is, on the class, I only define the, let's say, the properties and the fields. And any mutation that you need to do on the state, you do on the policies or the state update functions.
So for example, here, let me just see if I follow. So for example, let's see if I have anything here. To like increase the memory. So maybe the agent, a mutation happens. Make that not part of the class, the agent class, but have that be a policy instead.
Yeah, it would be a policy or a state update function. You need to make some design decisions. But I do not recommend you to mutate the agent state on the class itself. So for example, record opponent history. You are deleting objects. So you are mutating. But for example, things like initialize history or generate generic sequences. You are not mutating the state. You are returning. So this is a property, essentially. So it's fine to have those methods, provided that they do not mutate the inner state.
I see. Yep.
By the way, one thing that we tend to use a lot is Python data classes. What a data class does is essentially this init method. It initializes everything by default. It's a cleaner way of, let's say, creating those data containers with methods.
What do you call them? You said you use a lot. What was it called?
Python data class.
Oh. And you use them for what?
So one property of data classes is first because they make really obvious what are the fields, and second, it does have some properties that allows you to, let's say, to make the instance frozen. You do not need to use that. It's just that, on my experience, it generates cleaner code for the agent state.
So with that, okay, I'll take a look. I'm thinking something like enum type of thing, but I'll take a look into this too. I understand it, how to implement it. I'll take a look. But
yes, and another thing that I want to comment is that there is no right way of doing agent-based models, because I mean there are several approaches really. So using this list of objects is one approach. Another approach is, for example, you could simply use numerical objects like matrices and tensors. And on the cadCAD Study Group channel, I did send a link, which is an agent-based model based on the repeated prisoner's dilemma. And the formalism that is being used in that is really, let's say, you create several tensors for the agent's metrics, and you simply keep track of those tensors. So this is an option too. I do know that there are some agent-based models, not sure if they are open source or not, but I do know that exist. Some agent-based models where you have network of agents as being state variables. So the state variable would be a network X graph, and the elements would be, for example, dictionaries. So I'm telling you off that because, I mean, it's one Yeah, I mean, when you talk about agent-based model in terms of code, it can be really heterogeneous. And in the end, what we interpret as agent, I do think that, let's say, it's another important step. Because sometimes, for example, you show a matrix for someone, and someone looks at the code and thinks, oh, this is not agent, this is a numerical matrix. But you can interpret that as agents. And a lot of times you get way more performant results. You can explore way more. You can do calculations that are faster by just using the right formulas for the right question.
Right. Like in its simplest form, to be honest with you, the agent itself could really be just the strategy. It could be a list of the numbers in that strategy, and like all the other policy or state update functions, or for the mutations, like those are applied onto this. But at its core, the agent is the strategy that it's employing at any point in time.
Yes.
So that could be simplified.
And there is no right way. I do repeat that over and over again because there is a old adage in complex systems engineering, which is about, for example, what happens when you overly optimize it. So, for example, if you overly optimize that so that you have a numerical tensor, you are going to have super fast simulations, you are going to do a lot of parameter sweeps and Monte Carlo runs, and you are going to get lots of fast results, and so on. But at the same time, as you optimize that, as you optimize your representation, you are also more limited on how much you can explore. So it's one of the adages on complex systems engineering that, let's say, the more you optimize, the less you are optimized, because, I mean, you get faster results, but you limit how much you can explore. So it's somewhat contradictory. But in the end, there are it's design choices that you must make. So if you want to, let's say, prioritize exploring different forms, different mechanisms, it's best to have a non-optimized choice of how you are coding, because it gives you more flexibility. But if you are super sure about the questions and the approach, then it's all about design choices.
Thank you. This is much good feedback.
Could you describe a little bit about the different role of the cadCAD framework in those two circumstances? So in the case if you're doing an all matrix representation, is cadCAD primarily just handling the sequencing of steps, the iteration through the simulation, or how should we look at that?
So one thing that I always tell people is that cadCAD is really a framework, let's say. The goal of cadCAD is not to do the simulation. The goal of cadCAD is really to encapsulate the logic and having some helpers so that, let's say, when your logic is in place, you can scale it up quickly and you can share also the base framework within, let's say, underlying concept overview. But what I mean by that is that how you use cadCAD, it's also a design choice. So, for example, there are people that like to express their logic on very clean-cut steps, but there are more complex models where cadCAD is being used really as a wrapper, so that, for example, you have one partial state update block that represents a mechanism. Like, for example, when I talk mechanisms, let's think about a simulation Uniswap. If you are trying to, let's say, to do a simulation on Uniswap, you have the base rules of the game. Like, for example, you could swap one token for another. You could add or remove liquidity. But at the same time, you need the triggers. You need to trigger those actions. And triggering the action is a different step. So I think that one of the main use cases of cadCAD is really about that, about, let's say, allow you to decouple, let's say, for example, those different mechanisms, also decoupling, let's say, the rules of the game from the triggers. And also the triggers, I mean, they can have different natures. So, for example, on cadCAD, you could have something like, for example, the first partial state update blocks, for example, simulates the world through a stochastic time series generator. The second one, let's say, generates some action triggers based on the state of the world on the first one. And on the third partial state update block, you apply the rules of the games to the triggers. So it's really an attempt on, let's say, making sure that we can make models that are more plug and play in terms of their components. And also, it's an interesting thing because, I mean, if you try to create a dynamic, I mean, if you try to do a complex system simulation about anything, I mean, if you need to, for example, if you try to, if you do not use cadCAD, let's suppose that you write a simulation from scratch. And that simulation from scratch, you need that sequence of steps that occurs on each time. And also, you want to explore the parameters, you want to do the Monte Carlo runs. It's kind of curious because if you try to do that, almost all times, the structure on the for loops that you are going to create is exactly the same thing that cadCAD does on the backend. So, yeah, it's really just a way of formalizing, let's say, a sequence of loops that happens all the time.
As I make some progress on this now with some feedback and take a look through the documentation, where is the best place for me to, like, if I can't make the study group, but I kind of want async feedback or help, where's the best place for me to ask?
Yeah, if you post there's a Discord text channel with cadCAD study group, the same name. I think I tagged you in it to send some of the documents, but yeah, there hasn't been a ton of activity yet, but that's where everyone in this group is, and yeah, other communications too. So if you post in there, I'm sure some people will get back to you.
Yeah, I will do that. I will do that. I'm gonna let other folks. Thank you all for your feedback, for listening
really
to
great.
me. I hope it's interesting. If you have questions, ping me in that channel. I'm gonna run, but I got some good feedback and some directions, so I'm gonna keep in touch here because I have active motivation to
awesome.
see this one through. Yeah.
Yeah, great. Thanks for the presentation, and really interesting project. So excited to see the development.
Thank you, everyone. Yeah. Cheers for now. See you soon.
See ya. All right. And then let's see who's next. All right, Nico-san is on the list. Is he here today? Not yet. Okay. Actually, I think that was pushed from last week anyway, so. All right, and then Kojak left. So, Quiet Catalyst, we're actually on to your topic. You still want to share today? Awesome.
Yeah, let me see if I can share my screen. I haven't done this before, so bear with me.
Maybe in the meantime, just quick question. Danilo, are you aware of any like general documentation about how to structure an agent-based model in cadCAD? Or is the best way to basically look at other open source models that have been, or that are agent-based? Are those like
I don't think that there is a documentation. I think that the best thing is to look at at some existing models right now, and also have clarity that, let's say, there is no right way of doing agent-based model, because sometimes I like to tell people, because agents is really on the eye of the beholder, because if we look at the different disciplines, it's kind of funny, because, I mean, I come from a physics background, and, for example, agents in physics is what we call, for example, particles. So, I mean, I think that having the right analogy, having the right interpretation, I think that, let's say, can really work wonders for, I mean, having models that are informative. And, for example, I have some financial simulations that they do interpret, let's say, each Monte Carlo run instance as being, for example, a single agent. And it's kind of funny, because you look at the code, you do not believe that, but if you think, let's say, in terms of the interpretation, it would always make sense under some circumstances, like, for example, agents that are independent, that do not interact with each other. In that case, you can interpret a single Monte Carlo run as being, let's say, a single realization of an agent. So, yeah, there are some nuances, and I think that the best thing is really, let's say, to look into existing agent-based models so that, for example, you understand, let's say, the design choices that were made.
Mm-hmm. Okay, cool. Yeah, it makes sense. I wonder if anyone working on agent-based stuff in the study group, though, would be interested in like trying to generalize it, or at least give like a pros and cons to your design choices. Yeah, I don't know. If anyone else is, I'll probably mention that to Lemp. But if anyone else is working on agent-based stuff, that would be a cool topic to keep in mind.
That's an interesting topic, and I think you laid out the trade-offs very well, to where you get to things that on the surface don't necessarily look like agent-based models, but you sort of have these discrete entities that you're modeling. So I'm not able to share my screen without exiting and coming back. So Peter, are you able to?
Yeah, I can.
My learning journey.
Yeah, for sure. I should probably share my screen then. Okay. Should be going through now, and at the bottom here. Awesome.
Right. So as I mentioned, I've got an interest in token liquidity, and that relates to design of the token and the overall ecosystem. So I've been studying various approaches and collecting a bunch of notes that I've included in the journey here, and thinking about some learning goals. I think just being able to describe how people approach liquidity and what some of the trade-offs are in making token design choices is a good starting point. And if we think about why liquidity is important, simply, if you've got a deeply liquid token pool, it makes price discovery easier. It makes for a more stable token economy.
Sorry to jump in. I'm not sure if you changed something about your mic, but it got kind of windy or noisy.
Oh, that may not be me. So that's.
Yeah, that's me. I'm sorry. Going on mute.
Oh, is that someone else? Sorry. Yeah. Okay. Cool.
Okay. So thinking about how token design affects liquidity and the importance of liquidity in terms of creating a stable economy are driving my interest here. And so as part of this, I've been researching how different tokens take different approaches. Starting with bonding curves, you'll find different shapes of bonding curves. You may find some that are where the price exponentially increases with supply, others where the price starts out with a high rate of increase and then sort of levels off like a logarithmic curve. I think there are too many that are a straight linear curve out there, well, a straight line. In any case, I've included in the notes a handful of equations that can describe the bonding curves. And so as part of this exploration, looking to identify how the curve shape relates to the goals of the token economy, and as a baseline, I'd like to implement a cadCAD simulation that captures just a simple bonding curve and some agent interactions around the curve. So if you want to scroll down a bit, I've captured a bunch of notes in here and tried to keep them at something of a conceptual level to describe moving from the economy into how do we think about the purpose of the token, because the purpose of the token will affect design of the token mechanisms. And there you can think about, well, what kind of goals do we have for the token? In other words, what type of behavior in the token economy are we trying to create? And think about what types of mechanisms will drive that behavior, what types of incentives. And if you scroll down into the bonding curve section, I'm guessing most of the people on this call are aware that bonding curve is really just a way of sort of connecting two variables and describing how one variable changes as the other changes. But what I'm finding interesting, even at the bonding curve level, is that things can get somewhat complex depending on how you choose the shape or some of the initial conditions, or whether you allow the curve to vary over time. And so in the interest of putting together some system descriptions here, I have two system diagrams. One is using a single bonding curve that governs how people will buy and sell tokens. The other uses two bonding curves, one for buyers, one for sellers. I've seen both of those as examples, and again, it's an area for exploration in terms of understanding what are the trade-offs between those two approaches. So for next steps, I'm looking to get a cadCAD model working. Again, just sort of a simple baseline model where the dynamics of a bonding curve are modeled, and then agent interaction around the bonding curve is modeled. And would like to get one working, and then in a framework where different bonding curve shapes and initial conditions can be explored. So I'll pause there and take feedback. I guess I can mention that there are some samples out there from, I think, maybe the cadCAD repository or some other repositories. I found that to get them to run on the version of cadCAD, there's a little bit of updating. So if others are taking that journey, there's some syntax change in the most recent version of cadCAD that needs to be updated in some of the repository models in order to configure the experiment. And it's documented and it's fairly straightforward. It's just something you have to do.
Mm-hmm. Very cool. One thing I just like I'm connecting in my head. So you mentioned some of the questions that you were hoping to answer, and like trade-offs you were going to analyze with these simulations. Maybe it would be a good practice to like actually try and explain the kind of experiment that you would run in cadCAD to hopefully get an answer one way, or at least get insights in one way or another into one of those questions. I don't know if that's like maybe a later step in the process, or if it's actually helpful to do that in advance of like doing the work to build the model, because maybe you'll learn something about like how you have to set up your model in order to get these certain data to be able to answer the question that you were starting with. But yeah, just a thought. Maybe another next step could be like writing in words how you would analyze the trade-off of like two different slopes of bonding curves. Yeah, different experiments that you might run.
Yeah, I think it's a great point. And what I would like to get to is the ability to say that under different business objectives, you might choose particular shapes of bonding curves because of what they deliver. Also, in listening to you make your point, it makes me think about the potential risks around bonding curve behavior. So there are multiple examples out there of smart contract gone wrong and money flying out of an economy, a token economy. And so I think part of this inquiry is around whether these types of tools and processes can help us identify those things before they result in real loss. Yeah,
totally. Like edge cases concerns. Are you involved in the TEC at all? Token Engineering Commons?
So I'm in the Discord channel, but
okay.
Yeah. I think that's the extent of my involvement. Why do you mention?
I just mentioned because I know they recently launched their bonding curve and basically did like a participatory economics experiment where all of the community members proposed the parameters of the bonding curve and like starting price and slope of the curve, I think, and like all the other parameters. And so, I mean, they spent a lot of time thinking about the implications of certain design choices on a bonding curve and debating it. And like, so it could be, I'm sure there's people who are still really interested in bonding curves over there. And they obviously have some real experience, like analyzing the trade-offs of certain design choices. So could be a good resource for information or just like to chat with people who have some experience with it. So
interesting.
Yeah.
So that's the Token Engineering Commons, right?
Yeah, the Token Engineering Commons. And I'm trying to think of the best resources. If Decentralized SDGs is still in the call, he might have some ideas too. But I'll send like a few links to the debates. They were called param parties, and it was basically people coming to the meeting with the parameters that they decided to propose for voting, community voting, and then like they would have debates about like why I set this number here and why I think this number should be like that, because it will encourage more behavior like this and not like that. So that could be interesting place to start.
Oh, that sounds useful.
Cool.
Yeah, I was just going to jump in on that. I found the interesting thing to randomize and the unknown that you're basically trying to find is the demand that will come from either of your scenarios. So they had this sort of simple model where they did a bear market and a bull market, and it was just sort of two extremes, and that gave some insights into how each parameter set would look. But it would be probably more dynamic to see something really randomized. You're looking at the full spectrum, everywhere between the extreme bear and the extreme bull, and that would probably give you a better modeling and probably more precise parameters for the market behavior you're expecting.
So I'm curious, how did they simulate demand? Did they?
They played it in like I think, actually, in the back end, I don't know, but on the front end, it was just a simple, one was a bear market and one was a bull market. And you would just see, it was a binary choice. And I'm assuming I don't know what the actual parameters underlying that was. Okay. But yeah, they were assuming, I don't know, a certain number of buys a day versus, a very low number. I think it was really quite simplistic. And this is something where a cadCAD model could give you a much more dynamic randomization of really looking at all the different possible variables in between those 2 points. And then you could really model that different market behaviors and sort of help find your parameter that you feel most comfortable with, with the market behavior that you're foreseeing.
Yeah, interesting. Okay. Yeah, I'd like to check that out.
Cool. Yeah, I'll share some links. And Decentralized SDGs, if you have any to share too, that'd be awesome. I know you've been involved there. Cool. And Danila, since you're here, I'll give you also a chance if you want to comment on anything bonding curve related. I don't know if you've ever used cadCAD with bonding curves, but if you have any comments.
I'm thinking here. Not comments for now.
Okay. All good.
Simply pass.
Yeah. Cool. Do we have one?
Hey guys, I'm just this is Coach Risky. Can you hear me? Yeah. A beginner question here. I mean, again, when it comes to running simulations,
and then generating demand. Say we have a creator DAO, and we want to kind of understand the modeling around the creator token there. How do we typically generate demand? Like when you say you simulated a bear market or a bull market, are we talking volumes in terms of the number of buys and sells? Is that how the simulations are run?
It's a good question. Go for it, Danilo, if you had.
Yeah, about the bullish and bearish markets. So, I mean, the first thing is that you must understand that, let's say, a bull market for one can be the bear market for another. So it's always important to know, let's say, what is the perspective that you want to be bullish or bearish about. It's important to, let's say, make it clear, let's say, what is the stakeholder on that case. Having that defined, usually what happens is that when we set up the triggers for whatever is going to happen with the system. So, for example, on a bonding curve simulation, you are usually talk about the trigger for swapping and the trigger for the removing liquidity. Usually, setting up those triggers requires setting two things. First is what is the action that someone is going to take, and second is what is the intensity. And the thing is, when you generate those triggers, you are usually doing some kind of pruning motion most of the time. So there are different choices out there. Sometimes people simply toss a coin and go for it. Sometimes people do pruning motions that, let's say, are related to historical time series, or maybe there are several criteria how you could generate a random time series. But the thing is, if you are able to generate random results, you are also able to bias the random samples, in the sense that, for example, if you are using a Brownian motion, it's pretty straightforward to, let's say, to add a upward trend or a downward trend. So sometimes a way of simulating the bearish and bullish market is simply that. You simply bias your random number generator. And there are all ways of doing that, all kinds of ways to do that. Another option that is pretty popular is, rather than biasing the random number generator, you can, for example, test what happens if you have a shock. And about shock, the best way of simulating that is, for example, you simply suppose that at time step 100, so it sometimes can be deterministic, you simply suppose that, let's say, at this time, something special happened. And the thing that's special is, for example, everybody sells at once, or everybody buys at once. When doing shock testing, on my experience, it's usually a good approach to simply select a time step that have a very well specified action. And the reason being is that, for example, if you introduce a lot of random shocks, it can be hard to distinguish let's say, the shocks from the volatility. So if you make it super explicit where the shock is going to happen by how much, it makes it easier to analyze. And of course, this could be a bullish shock or could be a bearish shock, depends on the perspective. So yeah, those are some thoughts.
Got it. And just one last question. Sorry if I'm hijacking this session. Maybe I can take this up offline as well. Say there is a creator DAO where users kind of come into the DAO and pledge tokens on specific projects, right? And what happens is the creators of the project need to convert those tokens into US dollars to kind of, fund their project in real world, right? So basically there is a constant downward pressure here, sell pressure, right? In this kind of a model, how do we run, what kind of modeling can be done in the first place? That's one. And how do we even kind of run simulations for this kind of behavior?
So So it's not trivial because what happens is that there are things that are under the control of the designer, of the system designer, and there are things that are outside the control. And what I mean by that is that, for example, I think that one of the main utilities of cadCAD is really about when we are designing things that are under our control. So, because, for example, it's one thing to have a DAO, for example, where the creator has tokens and he simply sells out on the secondary market. And the secondary market is never under our control. I mean, we can do several hypotheses about that, but that's not under our control. What is under our control is, for example, what are the hulls that, let's say, I mean, what are the hulls of the game in the sense that, for example, how much the creator of the DAO can, for example, withdraw at once? Or by how much time he logs? Or, for example, is there some dynamical relationship with, for example, how, let's say, the rest of the DAO is doing? So this is under our control, and this is what we would call, let's say, in economics, the primary market. And I'm talking about that because if we do not have any hubs for the, for the primary market, if we do not have any hubs that is under our control, then we are left to things that are not on control, which, let's say, there is no straightforward way of, let's say, telling what's going to happen. The best that you could do is, is really science in the sense that you could, for example, identify similar cases over the history and see how it has behaved over time. Based on that, you could construct behavioral models. But I would say that this is more of a review and scientific workflow rather than a modeling workflow. So yeah, it's a complex question, and maybe the answer was a bit complex. But yeah, usually the simplified things that we can do is really, let's say, what we can do on the primary market. So because this is under our control.
Yeah, and I think answering questions like that is exactly what the simulation process is meant for. Like, to be able to experiment with different scenarios and see what happens. So it's not like there isn't really an answer of what happens when there's this. Oh, sorry, it's quite loud. Could you mute? Oh, okay, cool. Yeah. So I kind of forget what I was saying.
Value of simulation in answering these questions.
Yeah. So that's the point of running simulations, I think. And there's not really an answer to like what happens when there's downward cell pressure, but without doing some experiments first, because as Danilo said, it depends a lot on the other components of the system and what other possible actions there are. So it's not always a straightforward answer, but that's why these tools exist. So yeah, that could be a good project to pick up for a study group, though.
Got it. Yeah, I've already kind of created a copy out of the template. And the last presentation, I think the documentation was superb. I really liked the details, and I think I'd kind of pick up a few things from that.
Yeah, there's been great examples today too.
Yeah.
Cool. Okay, so yeah, Quiet Catalyst, we went on a tangent, but
that was a good tangent.
Yeah, it's super interesting. Was there anything else you wanted to cover related to your?
So I think everybody should be able to access this. So if other people are interested and want to provide feedback, I'm certainly open to that.
Awesome. Cool. Well, thanks for presenting. I'll stop sharing my screen. I thought there was one other. No. Okay. Never mind. Next is Zane.
Cool. Yeah. I figured if there were time, I'd just go and give an update on some of the things they've been jamming on.
Cool.
Let me just pull everything up. Let's do screen share. Into danger zone. Okay. So for those of you that might have missed it or what this is exactly. So I've been sort of working on this project that I'm calling a Pico DAO. And so it's basically how can you sort of time sandbox like sort of a DAO in the form that you would like a development sprint. So if you were to look at like over 2 weeks, is there a way that you can structure things such that the people that are contributing to the DAO ultimately get to decide how the DAO treasury for that particular sprint is like sort of allocated based off of the impact of contributions that the people made. So that's kind of a high level recap. This is just kind of how like the process works. So you have contributors, there's an accept contribution process, and then when the contributions are accepted, that'll either produce accepted contributions and new reviewers or just accepted contributions. The new reviewers go in the reviewers pool, and then they can also like sort of vote on contributions to be accepted. And accepted contributions then go to this impact rating process where people that have submitted or are part of this DAO can then rate the contributions. And so what they're trying to do is predict the median contribution score. So it's basically to say like what you think everyone else will like sort of rate this. And so that gets you an additional like contribution point. And the contribution point kind of works as an inflation mechanism. So if you miss the contribution point because you guessed something that was wildly off of what the median is for particular contribution, then you kind of, in a way, get slashed. So it's in your best interest to try and throw the dart as closely as possible. So all of this rating happens blind. And then at the end of the sprint, and this is this duration time, delay until there's a time signal. And then we go through and we process all the scores. And so this process is just basically to reveal like what people voted, how close they were to the median, and then figure out the allocation according to the weights, and then distribute the funds, or maybe it'll go through some sort of contestment with rough consensus that like, oh, this was wildly unfair or unjust. Okay, so that's like a quick recap of where we were sort of last week. And then this week, taking some sort of inspo here, I saw you did this causal loop diagram, and I thought, okay, let's talk about like sort of like the higher level view of like what it is that we're trying to achieve. This kind of mimics the development workflow within a system like PicoDAO. So what you have at a high level is like for some sort of product. And typically demand drives the production of more development incentives. It also drives like product needs. So it's like, oh, we need a widget that makes it easier to, I don't know, trade on XDAI. And so that's like a product need. And product needs then eventually add to like sort of pending goals for the DAO, or for that particular sprint, or that particular development arc. And so this becomes like a pending goal. Pending goals, the more you have of them, the sort of thinner everybody is spread, and the thinner resources are spread. So this is kind of like a negative to development incentives, like reducing the amount of development incentives per goal, and then ultimately per active participant. And so here we have these incentives, like the amount of like capital or funding for a particular sprint. And so that could be like 2 weeks of funding, it could be like 10,000, etc. And then these development incentives, the larger this pool is, the more active participants that you're gonna sort of attract. And so the more active participants, the less meaningful the development on a per participant per goal like basis. So why do you have active participants? back to because you want them to be able to sort of achieve goals. And achieve goals reduces the pending goals, and achieve goals, we hope, leads to a better product, which moves to this utility evaluation, which then increases the demand, which then sort of raises some like sort of price, or perhaps increases development incentive. So the pool of development incentives grows larger. So, and then sort of the final kind of glance at is like when it comes to pending goals, for pending goals, you have these kind of feature sets that you say to your roadmap. So as this happens, and as pending goals are not removed by like sort of achieving these, there is a delayed effect on the valuation, and in a negative sense. There's a perception that like maybe people aren't valuing things are in disarray and that kind of. And so that like lowers like sort of demand, etc. Okay, and so like underneath is just kind of like the story, just kind of in written out form. It's all in the learning journey, so it should be pretty easy to kind of dive through. And then the sort of, I guess I should like pause. That was a lot of stuff. So are people with me so far? Do they have questions?
I got a question.
Shoot.
So I've actually always kind of wondered what causal loop diagrams are used for, even though I've made them for some systems in the past too, but I just like find it kind of helps like with my understanding of it. But I could also see it highlighting potential bottlenecks in the system. So like some like I notice here the demand is basically what feeds the rest of the entire system. All those loops extend from demand. And so I wonder if like you've thought about that at all, like if there are any bottlenecks, or is that maybe what you've used this causal loop diagram to understand, is like, I don't know, yeah, how the relationships, how the entities are related, and where the bottlenecks might be. Just kind of a thought I had.
Yeah, that's a good question. So it is kind of a fuzzy thing. I think like sort of demand ended up like this idea of like product needs as well. Because like there comes a point in the project when it's early on, in which there is absolutely zero demand.
Mm-hmm.
And you're just kind of like figuring things out. In that sense, in a way, it can kind of be reframed. It's like the internal demand from the initial person, and what they perceive to be in need. And so in terms of demand, this is also gets kind of fuzzy here when it comes to development incentives, because part of that is like tied to utility and valuation, and like sort of price. If you have any sort of, yes, maybe it could be shaped more for a specific kind of workflow. And I kind of threw this in to maybe too broad. So like this demand I viewed as could be something like you have an NFT and you're doing a 10,000 PL launch. And so this demand could be like the demand super little pixies, super little pixels, or and so people are like, oh, and because let's say you sell out or you do a pre or you have an auction, then those demands result in an increased set of funding for development incentives, which doesn't always have to be the case. It depends on how the project structures it. But in theory, that means you have a larger pool of money to then go and develop. And typically what happens in these 10K PFP projects is that people will go through here and then they'll say, oh, okay, what was once now needs a game. And then they'll say, oh, okay, well now the game needs to do 50,000 different things. It needs to be a side scroller. It needs to be an RPG. It needs to have play to earn. And so what people will do is then they'll say, hey, look, let's just keep pumping up the things onto the roadmap. And then eventually what happens is they never things because it's just way too many things to deliver. And then the valuation itself goes down, which in turn should reduce the demand as well. And yeah. So I don't know if that answered your question.
Yeah, no, I think it does. Just understanding the flows around the demand entity a little bit more.
Do you have any thoughts on how that could be clear?
Well, so maybe there could be, as you said, a negative loop from utility to demand, just because if there are too many pending goals, it over time decreases the utility because they're not getting completed, which I think, like you said, decreases demand. So maybe there's an arrow also there. And then the other thing is maybe there's a difference between demand and demand quantity. I don't know, the amount of work that's needed versus the amount of money that's being paid for the work. So here there's a positive arrow that flows from demand to product needs and from demand to development incentives, but in reality they might there might be a separate demand, monetary demand, that flows into development incentives instead, because there could be high demand for products but no money. And
yeah.
Or the other way around.
Yeah.
When you're getting started, you may have funding, but low demand.
Yeah. Just taking some notes. It's a good idea to explicitly capture the monetary versus. Oh, I can't spell monetary.
This is a great discussion, guys. Just had a question here.
Yep, shoot.
So we are actually a DAO, created DAO, doing something very similar. It's just that we work on movie projects, right? One of the things that we are struggling with is definitely demand, right? So there are other projects that we've seen in the past which had launched at a time where there was really low demand, causing a dearth in the number of projects coming into the platform, and it kind of went into a death spiral, right? The valuation, the token valuation. So is there a way to kind of simulate this part, right? In terms of how launching a token with the right set of demand models, and how to evaluate the token accordingly. Sorry, was that clear or?
Yeah, I think it was clear. I think broader to the group was is there a way to simulate the launch of a token, and then sort of have an idea of what is demand, which is
and I understand that this again falls under this part where we don't have control over. I think the gentleman who spoke last time did mention that we can only simulate what we can control. But this is definitely a very known problem, and we're kind of breaking ahead.
Yeah.
So just throwing it out.
I think I kind of like. Danilo mentioned a few options. You could look historically at similar launches and take actual data from those and use that in your simulations. Or you could just totally randomize it and make like a huge range and expect everything from the lowest demand to the highest demand and do parameter sweeps or however you want to run the models to get an idea of different outcomes in those different scenarios. Yeah, or you could do shocks, kind of like one scenario with crazy high demand, one with really low, and then that kind of gives you like your bounds or something like that. But I guess it also goes back to the earlier answer, like it depends a lot on the other the other actions and the rest of the system too. I think so. Like, yeah, the outcome. Well, you'd definitely need to like run simulations on a variety of different demand degrees of demand to really understand the difference in outcomes.
I think also going through the process of understanding who the token user is and what they want.
Yeah.
That's basically a product design question, but it's obviously going to impact demand.
Yeah, totally.
And so from there, if you can start to identify those factors, that can feed into how you might set up a simulation.
Got it.
Yeah, like understanding the stakeholders and different profiles and what their motivations are and stuff like that.
Are people looking for a token that's going to appreciate in value, or one that's going to be stable in value, or highly liquid? Some of those types of questions.
Yeah. Got it. Makes sense.
Yep. Let's see. So, yeah, okay. So that makes a lot of sense. To be a little bit more explicit about what's going on from the monetary side versus just demand, because demand and price are not 100% one-to-one correlation. Okay.
Well, it seems like you have a positive feedback loop going. I'm not sure where to start it, but sort of running, if we start from demand through developer incentives and participants to achieve goals, so that results in a better product and higher utility. So that will get stronger as it grows, but then you have a balancing loop on the inside between development incentives and active participants. And I'm kind of wondering about that one, because there are popular projects that, because their popularity, continue to attract participants and grow incentives. So something to think about how that assumption applies in terms of the context where you're working.
Yeah. So I guess like part of my thinking around participants is that for this like sort of particular sprint is that it's not like sort of the incentive distribution is not constrained to say like a particular core team. So basically anyone within a particular sprint can sort of make a contribution. And so in that sense, let's say that any particular sprint, like maybe if you've seen the osmotic funding that people have been sort of talking about, so there's like basically a funding stream that people can sort of like stake tokens on, and then that essentially says like, oh, this project is going to get this much funding for some period of time. So if we were to take that and say abstractly, there's a pool of money that's like floated in for this 2-week period, but the access to the pool of money contributor impact, then the more contributors that you have, that would directly influence the incentives for that particular time period. Not necessarily in the long, because maybe a sense of time is what's missing. Does that make sense? So
I think so. So you're looking at this in the context of, for example, a 2-week sprint?
yeah, so it's a really time frame, or it could even be 1 month or whatever, but really shorter time frames. And then like kind of the thing that I really wasn't so clear about like how to represent is like the iterative nature of things in like the long run. So if this represents 2 weeks, and then you're going to go and run it again, and then another 2 weeks, and another 2 weeks, then you'd have like a repeated experiment. Sometimes with the same actors or not. Yeah.
Yeah, got it. So there is a perhaps a bigger loop happening here that captures that long-term perspective.
Yeah, there is a bigger loop that's not like this baby loop of like the 2 weeks. That would be like, hey, you've been running this for a couple weeks, and like now we have this larger event, and like because we've like crushed these goals in the past, the public perception is that the utility and the value is pretty much higher, which is a big assumption. An improved product is more utility evaluation. It's more like better product market fit. So, and then like measuring whether or not you've got that is like a whole thing on its own. But if we make the assumption that like you make a better product or you find better product market fit, that was going to, of course, increase the utility and valuation. People are going to notice that there's something valuable going on here. And so they're going to purchase more of the widgets, more of the tokens, more of the NFTs, or whatever it is that you're looking to exchange. And then that's going to give to the rise in increase in incentive. And because we have the increase in development incentive, now the active participant range has increased. And so maybe instead of there being less development incentives per active participants, it actually is flat. And there's like some part in the where these people that are active participants might be like getting insane development incentives simply because they were participating with larger incentives and they hadn't hit an equilibrium, where people found out more, oh, these incentives, development incentives are insane. And so they can capture in the sprint. So the lifetime of these is probably pretty interesting to look at.
Cool. Actually have like a bit of a tangent question for Danilo, I think, but you'll find it interesting too.
Shoot, I'll find it interesting.
So I'm just kind of curious, Danilo, if you have an opinion or perspective on system mapping diagrams in general. So we like are talking about the causal loop one, but there's a lot of options between stock and flow, entity relationship, block diagrams. Like from your perspective, do they each serve a different purpose and they should all be used, or is it kind of personal preference, or does it depend on the model? Like, do you have a favorite, or what do you think about system mapping diagrams in general?
Depends on the use case, but they tend to be very useful, and if anything, I tend to think that they are overlooked in the sense that a lot of times I see people that want to jump in right to the code, right to the model, but I mean, people a lot of times doesn't have clarity about, for example, what they want to model, what are the specifics of the mechanisms, what are the specific causes of the triggers. So having those diagrams, I think that they can help a lot to bring clarity about, I mean, what you want to achieve. And of course, depends a bit on the stage, because, for example, the causal loop diagram, I think it's one of the most powerful diagrams when you are dealing with complex systems, because, I mean, they help you to communicate, let's say, what you want to model, why do you have a question mark, because, I mean, one of the things one of the things that the causal loop diagram shows very clearly is that every system is made up of reinforcement loops and balancing loops. And it's always a question, let's say, it's always a question about, let's say, which one is stronger. So, I mean, finding out if the final loop is reinforcement or balance is always, let's say, a question that, let's say, I mean, it's always going to provide interesting answers. And about the stock and flow, for example, so those diagrams, each one they communicate a different thing. So for example, if we were to do a sequential order, I would say that the causal loop diagram tends to come before the stock and flow. Because on the causal loop diagram, you want to, let's say, scope out everything that, let's say, influences the system, that affects the system. So it's usually the first diagram that you are going to look for when you are trying to understand anything. The stock and flow, first because, I mean, creating a stock and flow requires you to have a fine understanding of the system. And, I mean, causal loop diagram helps you do that. But it is about the thing that, let's say, it's not all kinds of models that are going to benefit from having stock and flow. It really depends a bit. So, for example, agent-based models. If it's, for example, a 2x2 game, like, for example, the Prisoner's Dilemma, it's not going to benefit from a stock and flow diagram at all. First, because the game is relatively simple. And second, because, I mean, there is no stock. You are only computing the payoff. Stock and flow diagrams, they are usually more useful when you are, let's say, wanting to model something that it's, let's say, operates on the aggregate. So economic systems in general, like, for example, a token system, tends to benefit from stock and flow diagrams. First, because, I mean, it provides a very clear perspective on which you could interpret any, let's say, economic behavior, which is the fact that, let's say, everything, let's say, you always have accumulation points. Let's say, the token is always going to flow from one wallet to another wallet. And, I mean, of course, you do have the mints and burns, but let's say, beyond the process that does, let's say, generate or burn, the token must always, let's say, flow from somewhere to somewhere else. So, I mean, one thing that I do like about the stock and flow diagrams is because if you create a stock and flow diagram, you can readily convert that to, let's say, to a mathematical specification, or to create, for example, differential equations from that. Because every stock and flow diagram must hold the stock and flow consistency equations. So stock and flow diagrams are very powerful because if you have one and it's very well specified, you essentially have a specification for, let's say, a model that you could implement on cadCAD. So it's usually very fast to translate from a stock and flow diagram towards a cadCAD model. And also give us very, let's say, very concrete pointers about how to do so. So, of course, stock and flows are not going to solve every kind of problems, but for the questions and the systems that stock and flow describe, it is really a very powerful tool. So, yeah,
Cool.
Those are my thoughts about it.
Awesome, thanks. I saw Zane, you pulled up a crazy stock and flow. I think you're muted if you're talking. I think you're muted if you were talking, Zane.
Oh, there we go. Yeah, I was. Yeah, I was just gonna say I was just pulling one up. It's just like have a look at like one of those.
Yeah.
Like visually.
Yeah, they can get pretty crazy. But I guess, I mean, if it's possible to contain like an entire cadCAD model in a visual, then I'm not surprised it gets wild.
Yeah, I think this one's from the community power grids that C did a while back.
Oh, wow.
Okay.
Cool. All right. Yeah, we got a few minutes left, so yeah, keep chugging.
All right, and then I put together a different that I've been kind of like seeing And so basically, I'm starting to think that this will be an agent-based like sort of model. And so the yellow things are external state, like things that are not going to be really by the system. And then the other gray things are the system states. And then here's like sort of the update logic, which is like kind of the actions that the contributors or potential contributors can contribute. And so not really sure how, but I think it's kind of self-evident, but I don't know. So you have a contributor, they take some sort of action, or the population of contributors. So in order to be a contributor, you have to either be a founding member, or you have to submit a contribution that then eventually gets reviewed, and then once it's merged in, you become a contributor. And so the population is just like the set of potential size of developers or that could contribute. So if you had a Discord of the size of 5K or 10K or even 30 or 40, then that would be sort of your population contribute. And then actions are you can make a prediction about what you think the impact of someone's contribution is. You can make a contribution. You can abstain, so you can just like do nothing. Or you can sort of review someone's work and help convert them to being a contributor. And then system metrics would be the funding distribution, and then sort of like the number of contributors itself. And sort of the interesting thing here is also, I think like in between there around like, I think like the Douglas effect, which would be like switching. So how much funding does a person think that they're going to make with an impact versus like how much they get? But for me, that feels like because like, so like how people decide to like make a contribution or not make a contribution. But I think it's like sort of a base. And so like that's kind of where I'm at. And I'm just like after the conversation, I think I need to Causal and like sort of add in like sort of the pricing mechanisms and things. Yeah, that's it.
Yeah, I'd be curious. I don't know if this was on your list, but to create a second causal loop diagram that's like a longer time period, I would just wonder if it would look any different, or like what pieces would disappear, but if it exposes any new loops.
Yeah, I think that would be because like I think the big zoom out is like, why are you doing this?
Yeah.
and so like you want to see this form of development allows like enables like communities to have more like impact without having a strict core team.
Mm-hmm.
So like I think a lot of times what development teams end up doing is like their own dedicated core team and excluding everyone else out. Oh my God, I'm losing my voice. From like the economic opportunity, which is basically like the core team gets a salary, and then like sort of everyone else is like a freelancer contributor that's just like doing things from goodwill or one off as a bounty. And so the question is, can you reimagine so that way people have incentives to provide contributions that drive like the product?
Yeah.
And so if you just like from the outset structure things where people have incentives, does that like lead to more achieved goals, better product, and like more sustainability? So if you look at it like a project like Babel.JS, they only have like 3 full-time people and they can't afford like ever. There's not like enough like outside contributors to the project to sort of maintain it. So there's a lot of demand, but they're skilled enough to like go in and fix things in Babel.js and make them better. Has no incentive to do that.
Yeah.
Yeah.
Cool.
So, yeah.
Nice. Well, we've hit the top of the hour, but I think, yeah, we've had some awesome presentations. Super cool. Some new projects, and Zane obviously made some great progress this past week too. So, yeah.
I just had one question. Sorry.
Yeah. Sure.
Yeah. Sorry. Great stuff. I mean, I just wanted to know, did you use some kind of a general structure to go about these mapping diagrams, perhaps from an example or something?
Yeah.
Or did it come from your personal experience?
I think, well, so the diagrams, I think, are all, they all kind of come from other engineering disciplines. And yeah, so you can find some templates for them online, and yeah, I can share a few resources on that too. I'll just send you the names of some of them in the chat. Cool.
Thank you.
Awesome. Well, yeah, so we'll just stop there and pretty much do the same thing last week. Hopefully we'll have some new presenters, some more progress updates. There's, yeah, been pretty exciting progress so far, so it's been really cool. Thanks for coming, everyone. And Danilo, thanks for stopping by. I got some really great insight also from you. And yeah. Cool.
That was great. Thanks, everyone.
Yep, thanks all.
Thanks, everyone.
See you.
Thank you.
Bye.
Yep.